All right, Falcons, we're here for part two of our practice test video walkthrough. So we're going to take these 8 derivatives and see how we can help you make sure you understand it. Number 9 says find the derivative of 13e to the 4x. All right, the derivative of e to the x is e to the x. So here's what's going to happen. Everything stays the same. Then, chain rule, got to use it. The derivative of 4x is 4. So I'm going to multiply this by 4. Again, I'm not pulling the 4 out of thin air. It's the derivative of the exponent. And then 4 and 13 could get multiplied together. So 4 times 10 is 40. 4 times 3 is 12. 40 plus 12 is 52. So 52e to the 4x. And there's our derivative. Number 10, meant to be a really easy, straightforward question. Okay, the way I get my students to remember the derivatives of sine, cosine, negative sine, and negative cosine is they just start off with sine, write cosine, negative cosine. Okay, usually whenever we're taking trig derivatives or integrals, I write that at the top of my paper. And then if it's a derivative, it's going down. If it's an integral, we'll learn more about those later, it goes up. So I'm starting at cosine of x. So cosine goes to negative sine. Therefore, f prime of x equals negative sine of x. That is the answer. If you're saying, "Ooh, Mr. H, you forgot about the chain rule," well, we're taking cosine of x. The derivative of x is 1. So if you want to, you could put it like that, but you don't really need it. So f prime of x equals negative sine of x. There you go. Number 11, we have y equals tangent of 6x. All right, the derivative of tangent of x is secant squared of x, but we have to use the chain rule. Y prime equals secant squared of 6x. Then I have to multiply by the derivative of 6x, which is 6. If I put it together a little bit better, y prime equals 6 secant squared of 6x. There's our answer. Number 12. In this case, sine to the 5th power of 3x squared. So another way it might help you to look at this is to just realize it's sine of 3x quantity squared, but then the whole thing is to the 5th power. All right, so reason why I wrote it like that is because then you see the exponent is 5, and that's going to come out front. So 5 comes out front. And then this whole thing turns into the 4th power, so I can rewrite it the way they originally had it and say to the 4th power of 3x squared. But then I have to use the chain rule. The chain rule, in this case, we're taking sine of all that to the 4th power, so I have to take the derivative of sine, which is cosine, and everything stays the same, 3x squared. And then I have to use the chain rule one more time. The derivative of 3x squared is 6x, so everything has to get multiplied by 6x. When I rewrite this guy a little bit better, 6x times 5 is 30x, so I wind up with 30x. Then we have the 4th power of sine of 3x squared, and times that times cosine of 3x squared. And there's our answer, 30x sine to the 4th of 3x squared times cosine of 3x squared. Okay? Number 13. This is just one we have to memorize the formula for. All right? The derivative of cotangent is negative cosecant squared of x. But again, it's not x, it's 3x, so we have to use that chain rule again. So f prime of x equals negative cosecant squared of 3x times the derivative of 3x, which is 3. Rewriting it would give me negative 3 cosecant squared of 3x. There we go. All right. 14. Well, e to the 2x and natural log of 5x squared are being multiplied together. So when two things are getting multiplied together, we have to use the product rule. So here's what's going to happen. Y prime is going to equal, if I leave e to the 2x alone, then I have to take the derivative of natural log of 5x squared. So what we're going to do is 5x squared goes on the bottom, and its derivative goes on the top, which is 10x. So what I did was e to the 2x stayed the same. I then took the derivative of natural log of 5x squared, and it's 10x over 5x squared. We're then going to add to this the exact opposite situation. I'm going to leave natural log of 5x squared alone, and then I'm going to take the derivative of e to the 2x. The derivative of e to the 2x is e to the 2x times the derivative of 2x, which is 2. So now if I rewrite this, make it look a little bit prettier, we're going to get y prime equals, well, 10 and 5 would cancel out, be 2, and then there's going to be an x on the bottom, so we're going to wind up with 2e to the 2x over x, because 10 divided by 5 is 2, e to the 2x stays on top, and then there's one more x on the bottom, so that's good, and then plus 2e to the 2x times natural log of 5x squared. So that answer definitely gets credit. If you interchange them and you have it the other way, you get full credit too. Okay. For 15, we have sine of x over e to the x. So since we have both a numerator and a denominator that we need to take the derivative of, we want to use the quotient rule. So quotient rule is low d high minus high d low over low squared. So there's the quotient rule right there. If I use it on this one, we're going to take the low function, which is e to the x. So e to the x, the derivative of the high, well, remember it goes sine, cosine, negative cosine. So low, e to the x, derivative of the high is cosine of x, minus the high function, which is sine of x, derivative of the low. Well, the derivative of e to the x is e to the x, all over the low squared. Well, e to the x squared would be e to the x times e to the x. So if I have e to the x times e to the x, then couldn't I eventually simplify that as e to the 2x? So this is the correct answer, except it can be cleaned up a little bit. So just in case you have to clean it up sometimes on a multiple choice question, let's be able to do that. First of all, can't I factor an e to the x out of both the numerator and the denominator? I can. So if I do that, I get e to the x, and then I'm going to be left with cosine of x minus sine of x. Then on the bottom, I have e to the x times e to the x. Well, these e to the x's cancel, so my answer is cosine of x minus sine of x over e to the x. That would be the most simplified answer you could come up with. Okay. Again, even this would get full credit. All right. So I don't think we're going to penalize making a mistake from here to here, but if on the multiple choice test, you need to be able to simplify that. So you need to see how that works. All right. Same thing with 16. We have x squared, we have cosine of x, top function, bottom function. We have the rule right here. So the low function, cosine of x, and we want to use f prime, of course, because they did say use the correct notation. For d of x, we don't have to write anything because they're just asking us to find the derivative. So I'm not going to rewrite d of x because that would mean take the derivative of this, which we already did. So f prime equals cosine of x, the low function, times the derivative of the high, which is times 2x, plus, we're going to do the exact opposite now, the high function, which is x squared, times the derivative of the low. The derivative of cosine of x is, right over here, negative sine of x, over low squared. So cosine of x squared is not cosine of x squared, it's cosine squared of x. And when I simplify this guy, f prime is going to equal 2x cosine of x minus x squared sine of x over cosine squared of x. So there you go. That's a good answer. We can leave it like that. Alright, so we made it through those 8 questions. We will make another video.